everyone. My name is Preeti. I'm a UX researcher on the Jetpack Compose team. Super excited to be here and looking forward to sharing what we have been doing.
Awesome. Anyone else want to say hi before I start the video?
Hi.
Yes, hi. Oh, sorry. Go ahead, Alan.
Oh, hi. I'm Alan. I'm a software engineer on the Android team.
And hi, I'm Maytal. I'm a researcher with the UX team along with Preeti. Hello, everyone.
Awesome. All right. We will get started. And remember, you can ask questions. I just put it in Slack, so you can ask questions there, as well as after the video, they've got some more material to talk about and can do questions then as well. So enjoy.
In this presentation, we'll be talking about what API usability means and why it is a central tenet of API design. We'll also share some techniques we've been using to design and evaluate usable APIs. Now, this talk is to inspire anyone involved in the API design process, including those who are defining classes and methods for internal or public-facing libraries.
When we set out to revamp the Android UI toolkit with Jetpack Compose, we knew that we wanted to make it easier to do more with less code. It takes a lot of code, and sometimes XML, to say something with views. And when you're spending all of your app development time making things work at all, there's no time left for the things that today we consider to be polish. Motion, animation, those delightful little interactions that people open your app just to fidget with. If we save you time with the basics, then you have more time for adding that excellence. But nothing comes for free. One person's boilerplate is another's expression of explicit intent. That boilerplate code is what tells casual readers how things actually work and helps them form a mental model. Complexity is kind of like thermodynamics. You can't destroy it, you can only move it around and compress it. You can say a lot in a very small space with Compose, and the trade-off is that every token and its placement is full of meaning and intent. It's a high-risk and high-reward trade-off, and we needed some help to set the patterns and standards that our code would follow to set those examples. And that's where our developer UX and UX research teams come in. Today, we'd like to share with you a bit about how we did it, some of our process, the way that we think about the problem space, and to share some tools and vocabulary that you can use with your own teams to design more usable APIs.
Throughout the talk, we'll be following the development of the button element in Compose, starting from the Vue and XML-based button that existed prior to Compose. As Adam mentioned, the Vue framework didn't always map well to what developers wanted to do with it. And over the past 13 years, what users expect from a UI and what developers need to do to achieve that has changed significantly. So we know things are difficult, and we can rationalize why. But how do we systematically identify the problems that we need to solve? And how do we evaluate whether our solutions are any good?
Now, to design products for people and to understand if a product is usable, you need to know who will be using it and how they'll experience it, right? So when it comes to software usability, it is common to think only of the end user, right? The app's end users, the customers, and their experience is what really counts. But there's actually a spectrum of users we should be thinking about, all of whom are working towards the same goal, right? So from the end user to the app developer and the API designer, all are users. Right? So for every human tech touch point, we have users. In fact, developers, including your teammates, are users too. Specifically, API users are developers who use an API to write their programs or API for their users. Right? Now, every developer travels a journey, with a journey consisting of several tasks that move them closer to the goals that they want to accomplish. And every developer's need drives a specific approach.
So now we agree that developers are users too, and their experience matters. Let's understand what it encompasses. As a developer goes through a journey to achieve a goal or accomplish a task, their interaction with the API also involves the tools and documentation that supports its usability. That's why when we aim to design a usable API, we also examine all parts of the journey that contribute to the developer experience. In this example, a developer is interested to integrate Compose with an existing app architecture. In that journey, a developer uses the documentation along with the IDE utilities such as autocomplete, some code snippets, maybe from Stack Overflow, to give it a try. In that process, the developer might test and run their code to check on their progress frequently. Starting with a new API can involve some amount of learning, even with support of tools and documentation. And one could spend quite some time mastering an API. While this seems like a huge uptake, it might be worth it, especially if it results in a huge productivity gain. This can also prevent a developer from misusing the API. So what is API usability? At a high level, and with the design of everyday interfaces, we can combine concepts such as learnability, productivity, and error prevention. In our research, we found that learnability of an API has huge impact on the other two components. For instance, most developers learning RxJava agree that there is a steep learning curve, but the tree bears fruits once the learning is complete. However, for Compose, we had a different goal in mind. We wanted to allow developers to quickly and easily learn and use the new UI framework and gradually build more skills as they try on new and more advanced implementations.
So since we started with some very specific usability goals for Compose during its development, let's go ahead and take a look at some examples where these kind of formalizations really helped us. So one sticky challenge that we faced within our team is that in some of our design discussions and when we were reviewing developer feedback from user research, we recognized the lack of a design language that's centered around these developer needs and abilities. We would hear someone say something like, I don't understand this API, or this isn't intuitive, but it was hard for us to determine what the underlying problem was. And we weren't able to determine why some of these concepts were harder to understand and others weren't. So this is where we look to something called the Cognitive Dimensions Framework, a tool that a few of the members from the Android Developer UX research team were familiar with, and that several of us on the wider Android API Council had started using to evaluate some of their Android platform and Jetpack APIs over the past several years. The CDF was originally designed as a tool to evaluate and describe the usability of a programming language, but it was later adapted to evaluate some APIs as well. So this gave us this common language for our team to collectively understand our users and their goals and their tasks. We'll talk a little bit about parts of what we used, but we really encourage folks to read some more about the framework. This is how we adapted it for our usages on the Android team, and you'll see some kind of other formulations of it elsewhere as well.
So back to the ubiquitous button. At first glance, this might seem like a simple use case, a colored square that does something when you click on it. But as you enumerate the features the developer needs out of a button and how they interact with those features, there are many aspects that make the design more complex. For example, discoverability. How does a developer find the API? Where does it show up in autocomplete? Or naming. What conventions make sense? Can the APIs be self-documenting? Or parameters. Does ordering matter? Are defaults or nullability important? And so on. But let's back up and take this one step at a time. Early on in Compose, we laid out several use cases and attempted to design an API surface to fit those developer needs. For instance, we included some parameters that can come from the theme as defaults, while other parameters are required. And we decided to include two versions of button, a button that accepts a string parameter for text, and a button that accepts a composable lambda parameter representing generic content. And the intention here was to provide APIs in two distinct layers, a simple button that just has text, which is easier to implement, and a more advanced button that has more flexibility around the content that's placed in it. However, despite the forethought and all of the upfront discussions, there were still details that were overlooked and more changes were necessary. We were able to uncover this through user research.
Thanks, Alan. To validate our assumptions and design approach, we invited developers to join some coding sessions to complete simple programming exercises, right? And they were using like the button API. Now, the programming exercises involved reviewing a code lab, followed by some code refactoring to reflect the screenshot that we have here, right? And we asked developers to think aloud during the session so that we understood what they were really thinking and where they were coming from in terms of their feedback. And we observed developers experiencing a choice paradox when choosing one over the other, when moving from like the string overload to the lambda overload, making it challenging to incrementally customize a button. Right? A common request we heard from developers was to add a text style parameter to button with like a string overload. Right? So here's a representative quote that we heard. It'll allow for customizing the internal text style without having to drop down to using the lambda overload.
So our intention in providing the string overload was to make the simplest use cases simple, but this discouraged developers from using the overload with the composable lambda, which led to requests for extra functionality on that string overload. So not only was the existence of these two separate API shapes confusing to developers kind of intrinsically, but it was clear that there were some fundamental problems with these primitive overloads. Now, the primitive overloads by design allow developers to avoid using the composable Lambda overload in exchange for fewer customization options. But developers consistently asked for more of these options as their use cases evolved in the places where they were already using the primitive overload, almost to the point where we were being asked to provide the full API surface of the text composable as part of the button as well. So if the primitive overload doesn't have the functionality that you need, your only option is to drop down a level. So you use the composable Lambda overload, you copy paste the internal implementation from the primitive overload, and add your own changes to it. So this unfortunately creates a bit of a customization cliff, which can discourage developers from moving to the more flexible and composable APIs, since this kind of requires this moving between layers, which can come across as kind of daunting. So we intend for this sort of thing to be very cheap and natural to do with Compose. Composable functions are meant to be much smaller than custom views, and they're built in layers that you can reuse. But those convenience overloads still need to be applicable enough outside of these trivial code examples to be worth their weight in the overall API surface. So we saw this before with Android's list activity-based class, dating way, way back to Android 1.0, I think. Developers would start with a simple use case that fit the API well, but over time, a bunch of workarounds and gymnastics would start to accumulate in their code just to try to avoid that deeper refactoring. So the cognitive dimensions framework would say that these APIs ask the developer to make a premature commitment. You're making a choice of A or B, but without the context to understand how your code will evolve around and be influenced by that decision later on. So our convenience overloads were asking developers to predict the future of their own code.
Adding on the challenge with asking developers to look ahead prematurely, we realized that the working framework cognitive dimension can also help us better understand developers' expectations and ultimately reduce unnecessary complexity. While the button API facilitated exploration, there was a gap between the developer's mental model, they thought the overloads worked, and what we had envisioned. Our design discussions led us to remove the primitive overloads of button, leaving behind one API for each button that contained a composable Lambda parameter for its content. We started to refer to this general API shape as a slot API, a shape that is now widely used across components. A slot refers to composable Lambda parameter, which represents arbitrary content inside a component, such as text or an icon. When going back to gathering feedback, we observed that the introduction of Slot API made button and other components much simpler. It reduced the number of unique concepts across components, making it easier for developers to start a new component or move between components.
Thanks, Maytal. That's a great example of combining a shared design-centered language to identify issues with an iterative approach to address them, resulting in a more usable API. In addition to running user studies, the Compose team has taken a few lower-cost approaches to assessing and iteratively refining APIs. And even if you do have a dedicated research team to run usability studies, we'd still recommend integrating these methods into your workflow. One lower-cost approach is cognitive walkthroughs, and more broadly, design and coding sessions, which can bring together a more diverse set of viewpoints and can be useful for high-level brainstorming and refining user goals at a slightly higher cost. Focus coding sessions can be set up such that some members of your team act as evaluators, while others take the place of users by actively writing code and thinking aloud. And you may already be doing design or code reviews, which are great ways to get pure feedback on implementation. But you can also use these as a very low-cost opportunity to assess API usability. Code review is where aligning on a common design language is critical, so that when something seems off about a class structure, you can have an efficient discussion about what it is and why and how to address it. No matter what approach you take, though, it's critical that you take some action to integrate user-focused thinking into your development workflow.
To summarize, we introduced the concept of API usability and cognitive dimensions framework with an example for how we were able to make button API in Compose more usable. Right? We hope this provides some inspiration for you to incorporate in your own work. If you're interested in sharing feedback and helping shape the future of Compose, here's a sign-up link for you to participate in more future sessions. Thank you very much for listening to our talk.
Yep, cool. All right, so we will be sharing this resource with everyone on this call on Slack channel once this has been shared. But just to keep in the same spirit with how the right before how we ended the video, we were actually starting to talk about how how our team has been evaluating APIs, and so we wanted to actually take on one of the questions our team has been asked very often, and a lot of it has actually got to do with modifiers API. The most common question we have heard is, what were some of the decisions the team have made while designing the modifiers API. So we thought we'll talk a bit about the life story of what went into the modifiers API. So for that, we would have to time travel maybe to about a year ago or so. So if you can move on to the next slide. Early on, everything in Compose was a composable, right? So you would use composable to specify how to lay out something. Like for instance, like in this example here, you would add padding around text, like the code here. And one of the things we wanted to do with this early concept was we wanted to actually find out from the community if this made sense. Right? Does this align with developers' expectations? And for us to be able to do that, we actually went back to one of our common techniques, which was also what was shown in the video with the button API. If you can actually go to the next slide, this was more like an in-person coding session. We invited developers from the community to join us for a 60 or a 90-minute session. We had a machine already prepared with the right version of Studio and Compose, and what they had to do was basically review some sample code and add more code to reflect more like a design mock. And we asked developers who joined us during the session to kind of think aloud so that we understood what was their thinking behind how they approached using the API. And the way this was set up was, one of us researchers, we were present in this room, and we were trying to ask basically clarifying questions while the rest of the team kind of silently observed via a video call. So I was acting more like a fly on the wall. And then if you can move on to the next slide, one of the things that really got called out in this early set of research sessions was that padding as a component of its own is not super intuitive, right? And this is a classic quote that represents what we kept hearing during these sessions. Padding is a widget of its own, which is not very intuitive with how I do in XML. Right? I see it as an attribute or a parameter that I can set for a component. And additionally, one other thing we started to also notice was, if you actually go to the next slide, we observed that it was actually unclear for developers as to how to implement padding in the first place, right? So in this code example here, a common question that got raised was, what would happen if one applied padding like the code in here? Would it be around one of the texts? Would it be around both the texts? Also, how are the texts oriented, right? Are they going to be laid one on top of one another? Are they going to be laid side by side? And essentially what was happening here was padding was operating in this context with multiple children, right? And this required developers to specify how the children had to be laid out. But padding didn't have that usage built in. And this made it difficult to differentiate padding from column, for instance, right? So in the same example, there's padding and there's column, and that was a bit ambiguous for developers. And at this point, I'm actually going to hand off to Alan to talk a bit more about what we did next.
So if you look at other view layout systems or other layout systems in other languages, you may not be surprised that this is the conclusion that we reached. Next slide, please. And especially for developers that have been working with Android, the idea that a set of metadata, things like padding and other things that are modifying how widgets are displayed in a view would be associated with the view that's wrapping them. So that hierarchical system doesn't make a lot of sense if you've been looking at HTML or you've been looking at Android XML. So we went back to the drawing board, and we thought about these modifiers as things that are associated with the container that the objects are in and is modifying how it interacts with them. So we are calling them modifiers and these are expressed as something that's associated with the objects instead of wrapping the objects that it's altering. Let's move to the next slide. Hopefully this will make a little bit more sense. So going back to the example that we had before, we've made padding a modifier on the column. So it's obvious that the column contains the text and that the layout padding is something that's associated with the way that the column is being rendered. Next slide, please. One of the other properties that we wanted to preserve is ordering. So when you're nesting things, the ordering is inherent. Here we're using the plus sign to show that these are things that can be combined, and plus is okay for implying ordering. So this reads as adding a text composable within a layout of 40 dips with a background color solid green, while also ensuring that the size of the text component is 20 dips. Again, the order matters, which I don't know if we have we don't have an example of the ordering being changed, but I think we'll talk about that a bit. Next slide, please. I'll hand over to Maital.
Thank you, Alan. So with any of our usability methods, we try to, when we come into this point where we want to evaluate if things make sense, we try to really focus on the top questions that we have. So the teams at this point was very excited about this new concept of modifiers, but we wanted to know how all of you Android developers thought about this. So we knew that ordering can trip developers until it learned consistently over time. We still wanted to validate if modifiers as a concept can be grokked and how long it will take, and if there are any risk with incorrectness during the learning process. So we did uncover interesting sites that led to some more rethinking about modifiers. Next slide, please. So in trying to understand developers' reaction to modifiers, the UX team took a different approach. So as we continue through this journey of designing modifiers, you will hear different techniques that we use to kind of get better understanding of how developers will approach this. So we wanted to hear developers' thought from a broader community around the world. And this was also there was also a need for finding the balance of having opportunistic conversations, like more spontaneous conversations, while allowing time for developers to explore a concept enough for them to be able to articulate this feedback. It's a design challenge by itself for our testing. So we used a different method to kind of go about this research question. And we asked developers to complete a homework and kind of practice and use the modifiers over a week. And then we invited them to talk to us after that experience and share their thoughts and practices and the code. Next slide, please. Just want to make sure yep, okay. So as this quote is kind of one of the representative quotes that we heard, and I'll read through it. Plus was equated with and was confusing, especially in situations where one could set a modifier parameter twice. So let's figure out why it was confusing. The very first red flag that the team got was called out with the usage of the plus operator. While many developers associated plus with the operation of addition, thus expecting to see compound results, some related the plus sign with the operation of overriding, thus expecting to see the code behave based on the last modifier item. Because the plus being commutative with numbers, many assumed that the order did not matter, which was incorrect. When we have observation like that, that leads to many conclusions by different approaches or mindset of developers, we know that something needs to be clarified or disambiguated. Next slide, please. I'm going to read through this quote first. Specifying modifiers in order made sense in theory, but is both tough and confusing to code, comprehend, and debug. And that's really a red flag for us. As expected, the ordering also was confusing by most. We heard several talk about the cognitive overload this could potentially introduce in coding, not to mention difficulties with knowing when order actually influence the outcome. And that's a major risk. If we expect developers to continue being productive, they really wanted to operate on this notion that their steps they're taking, they have confidence that they will produce that direct outcome. So modifiers we receive as a single entity, and hence the most common feedback we heard was that adding a modifier in the end will be very helpful, especially when iterating. I think I'm going to leave this back to you, Alan, to continue this journey of how to improve API, the modifier API.
Thanks. Next slide, please. So what did we change? Next slide, please. We sort of struck a balance between something that was concise and familiar for developers. So we ended up with a structure that looks sort of like a builder pattern. And these are actually Kotlin extension functions. So you can chain a bunch of these together. Ordering does matter as opposed to something like plus, where you would expect to be able to shift things around and not have any change. And this also gives us the opportunity to attach callback events. So here we're giving an on-click event to the clickable property. Extension methods allows us to improve the namespace. So we can also put these in different modules, and autocomplete works a little bit better when we have things set up as extension functions. Next slide, please. So the ordering here still matters. And one thing that we wanted to note was that if you change, let's see, I think with this one, if you flip padding and fill max width, you actually end up with a different output. So our hope is that, and I think what we found when we sat developers in front of this, was that compared to using plus to combine all of these together, having a method chaining paradigm made more sense, that the order matters. All right, and last, we want to encourage everyone to visit the website and the resources. Next slide, please. So these are all great resources. We also have, next slide, an article about the design of Jetpack Compose and these slides themselves. And I think, hopefully, Maytal, we'll have some additional resources available on the cognitive dimensions. Is that?
So yes, some of the papers listed here are kind of the baseline of understanding how to use the cognitive dimensions. And some of the extra resources there are actually giving you all some stories and more examples like we shared today.
Yes, and I'm already seeing some questions on Slack. We'll try to address some of them, but please feel free to drop more questions. We are assuming that this Slack should be live for another day, so we'll continue to respond to those questions asynchronously. But for some of the questions that that came up, I think early on was this question on diary study. We should be able to talk a bit more about that. Actually, the homework paradigm is a version of diary study, and the concept behind that is basically to give developers the opportunity to kind of explore and play with an API, so they can speak to it much more about what they really liked and what worked and what does not really work, and as opposed to a more like a live coding session, which can be more like a first encounter, especially if the API is not publicly available, and it's like developers just looking at it for the first time. There might not be enough time to like in a 60-minute session to read through and understand the capabilities of an API. And so we, as Mittal was mentioning, we tend to use different kinds of research techniques depending on the requirement, like what is the question we want to answer. Lauren, your question was, I'm not sure if I answered your question about diary study. Was there anything specific you wanted to know? Maybe you could unmute and ask us.
Yeah, I was just looking at the diary study and the other study you had for the usability study, and that seems really great. But just in terms of for just a regular API, it seems a little heavy. So I just was wondering if you had any suggestions for something a little bit more light that like just a small team could do.
Yeah, and I think
Yeah, maybe we can
Vita should be
navigate
able to
back
take
to the
that.
slide.
Yeah, I
We
think
had
this
a
should
slide
be
introduced.
this should be on page 35. Um, yep.
Yeah, I agree. Design research for APIs is definitely resource high, and it takes time and also practice. And what we think about in terms of light methods is essentially any code reviews can be adapted to do API usability evaluation. So even if you do code review together or peer review, you can take the user perspective into mind and really think about the steps or the conceptual load that each step will carry, and think about how developers will code against those common tasks that your API needs to support, and try to figure out what makes sense and what doesn't. Of course, it's much better to get feedback from real users, and they will provide the most direct feedback to you. But if you don't have that ability or don't have that time, I think just taking those steps and doing code reviews or even a cognitive walkthrough, if there is a UX person that can help you set that up, really thinking about how developers will actually go through some of those common tasks will help.
As far as highly scalable processes go, what we do on the Android team for Jetpack as well as the platform SDK, every single API gets looked at. So we do API tracking that sort of condenses everything down into a single file just for efficiency's sake. And there are eyes on every single API that's getting added, and that goes through code review. And then there's a secondary process of a committee review where we have somewhere between like 3 and 5 people that are looking at every API that goes in. And that works okay. That loses a lot of context. So one thing that we do like to do is when we have a larger cohesive feature, have a design doc review for that, have sample code to look at. One thing that can work really well is if you're writing samples for integration tests, you get, and then you can write tests for those as well. You get integration testing for free, and you get effectively for free, and you get a sample of code from a developer's perspective to look at and say, does this meet my expectations? Is this being used the way that I would expect?
And maybe just to add to that, there is one slide with some heuristics that we have around the cognitive dimension framework. So if you go back in a couple of slides, there is a kind of an overview.
Page 17.
So just to give you an example to what to look for in terms of usability feedback, we really like to focus on the core usability. We want to make sure that things are intuitive, they're readable, they make sense. They go from like what they say they do to actually what they do, to look for consistency, because when things are inconsistent, that breaks learnability of things, and then user will make mistakes. And we touched on this problem with premature commitment. We're trying not to give too many options right from the beginning before the developer will be able to fully make commitment to one. So try to reduce the number of choices at the beginning for common tasks, and then gradually as they build knowledge, they were able to make those choices. And obviously if you are making one choice, it doesn't mean that you can revert. So let's also be flexible about that. So this table can give you just high level of ideas on what to look for when you do those evaluations.
Yeah, and please be sure to review some of our reading list, because some of this is described in much more detail in there.